Hello, everyone, and welcome to the second part of our session. And for today, I will be giving you like a more complicated problem, okay? And that is g of x equals negative 1 half times the logarithm of 4 times the quantity x plus 2 with base 2. So first, let us try to determine the values of your a, b, c, and d. Okay, your a is negative 1 half, right? Let's use another color. Your a is negative, redundant, negative 1 half. Your base is just 2, right? This one is 2. And the value of your b is positive 4. Your c is negative 2. It's not positive, okay? It's negative 2. And your d is no d, so 0. All right? So from there, let us try to determine the transformations in our parent function. By the way, our parent function here is the logarithm of x with base 2. And usually the graph looks like this, right? There. And it has the vertical asymptote at y-axis, or simply x equals 0. So it's going to transform later, so let's see. So first, there's a negative here, and that means that, okay, let's just try to write that. Transformations. Okay. There will be a reflection, right? Reflection over what? Over x-axis. All right. And it's 1 half, so there is a vertical shrink by 1 half. And your base is 4. I mean, the value of b is 4, okay? So we are expecting a horizontal shrink, okay, by the reciprocal of 4 is 1/4. All right, and for the value of this c right here is negative 2. So there will be a, let's just use here, horizontal shift, or let's just say left. How many units? 2 units. Left 2 units. And we don't have a d. All right, so these are the different transformations of our graphs later. Okay, so let's try finding first the vertical asymptote of our graph. So let's just try to remove this real quick. Let's try to recall that this c value here determines our vertical asymptote, and that is at x equals negative 2. So it's gonna be somewhere here, okay? At negative 2. All right, so look at your b value here. It's positive, right? So we can expect that the graph will be contained here on the right of this line here. It could be like this or like this, whatever. So as you can see, since it's on the right of that number, negative 2, okay, we are expecting that there will be a x and y intercepts, okay? So first, let us first try to find the value of our x-intercept. Okay, we know that in finding the x-intercept, we just let y be equal to 0, right? Y equals 0, or simply the g of x be equal to 0. So let's do this. 0 equals negative 1 half times the logarithm of 4 times x plus 2 with base 2, right? So what we can do here is we can divide that by negative 1/2 first. So we can isolate the logarithm, or we can divide by negative 1/2 if that's what you want, but doesn't matter. Okay, say divide by negative 1/2 if you want this. Divide by negative 1/2. So we can remove this because that's equal to 1, right? And 0 over negative 1/2 is still 0, right? So 0 equals the logarithm of 4 times x plus 2 with base 2. Let us try to recall that we have to express this in exponential form, right? So don't forget the form. So your base is still equal to 2. We know that this whole thing is an exponent, right? So the exponent is 0, this. So 2 raised to 0, and it's equal to 4x. 4 times x plus 2, okay? 4 times x plus 2. Okay, so 2 to the 0 is equal to 1. So we have 4 times x plus 2. What we can do here is we can divide first by 4. Okay. We can divide by 4. So that's 1/4 equals, cancel this out because that's equal to 1. Okay. So x plus 2. So subtract 2 to both sides. So we have negative 2 plus 1/4 equals x. So let's just try to simplify this further. So 4 times negative 2 is negative 8 plus 1 is negative 7. So that's equal to negative 7 over 4. Okay? This is your x-intercept, and that's actually somewhat negative 1.75. Negative 1.75. Yep, so it's approximately negative 1.75. So let's just check that real quick. 7 divided by 4 is, yeah, it's negative 1.75. So it's gonna be somewhere here. Okay, there. Suppose that's negative 1.75. Okay, we know that there will be a y-intercept, right? So let's just find that y-intercept over there. To find the y-intercept, we know that we let x be equal to 0. So y-intercept, you just have to set x be equal to 0 and you're good to go. So y equals negative 1/2 times the logarithm of 4 times 0 plus 2 with base 2, right? So let's simplify that further. So y equals negative 1/2 times the logarithm of 4 times 2, just simplify that now, equals 8, right? 8 with base 2. All right, so y equals negative 1/2 times, what is the value of logarithm of 8 with base 2? You have to remember that that is an exponent, right? So what do we raise to 2 to get equal to 8? What do we raise to 2, question mark, to get equal to 8? And that's equal to 3 because 2 cubed is equal to 8. So therefore, the logarithm of 8 with base 2 is equal to 3. Okay. All right, so y equals negative 3/2, or simply negative 1.5. So it's gonna be somewhere here. Okay. So since the points are like that, so the graph would look like this. There. Assume that it's very nice, okay? It's so hard to graph this. All right. So this is, just label the points. This is at negative 7, 4, 0, and this is at 0, negative 3 halves. Okay. Since we know that every logarithmic function or the parent function has the point at 1, 0, right? At 1, 0. Where do you think will this point be moved or will go? So just go to your A, B, C, and D values and make sure that you are operating it well. So your A and D will affect your Y values, right? And your B and C will affect your X values. So let's start with your X values. So 1, multiply this by, so your B is 4, right? So you have to get its reciprocal, and that's 1/4. Okay, 1/4. So multiply X by 1/4 and then subtract 2. That's your X values. And for your Y values, this 0 right here, multiply that by negative 1/2. Okay, so 0 times negative 1/2. And then, so there's no D, so it's still 0. Okay, so 1/4 times 1 is still 1/4 minus 2. And that's equal to negative 7 over 4. Oh, surprisingly, it's still the x-intercept. So 0.10 goes to negative 740, which happens to be your x-intercept. Okay, so let's just try to remove some of these here, so we can write also the other informations that we will be needing. Okay, so for the domain here will be, as you can see, it's the graph is contained to the right of negative 2. So okay, so the domain will be set of all x such that x is an element of real number, but your x is greater than negative 2, right? And for your range, well, it's all real numbers, as you can see. Set of y such that y is an element of real number. And for the n behaviors, just abbreviate that. Okay, that's n behaviors. Okay, as x is going positive, look at that. As x is increasing in number, the graph is decreasing, right? So as x approaches infinity or positive infinity, the graph g of x is approaching negative infinity. Okay, and then as x approaches, what is that? It approaches negative 2, because you cannot have x to the left of negative 2. So as x approaches negative 2 here, okay, from which side? From that side. So from the right. Okay, so g of x is, okay, it's increasing, right? Okay, one more thing, the interval. So as you can see, the interval, let's just try to write it here real quick. Okay, yes. Okay, so for the interval, as you can see, the graph is decreasing, right? From left to right, it's decreasing. So it's from negative 2 to infinity, to positive infinity, the graph is decreasing. Okay? Okay, next example. I still have one more. So let's try to find first all the A value, A, B, C, and D values. This is your A, this is your B. Your C is here, and that's equal to -1, okay? Oh, it's okay, and your D is, okay, it's -4. So what are the different transformations? So let's use this bottom right here. Transformations. Okay. Let's do this is slowly but surely, okay? So your A is 2, and that's your vertical, a vertical stretch by a factor of 2, by 2. And this B right here has a negative, right? So there will be a reflection in which axis? Reflection over y-axis. All right, and there's 3 here. So therefore, we expect that there will be a horizontal shrink, okay, by a factor of 1/3. You always have to get its reciprocal when it comes to B, okay? And for your C here, it's -1. So we are expecting that there will be a shift to the left. So left, just right, left 1 unit, and then down your value of D, down of 4 units. Okay. So after getting all the transformations, let us see first the vertical asymptote, and that's your value of C, and that's -1, right? So -1. So at -1, let's use blue. Okay. So this will be your vertical asymptote. That's your value of C. Okay. Now let's see if the graph will be on the right or to the left. So since your B is negative, right? Your B is negative. We are sure that the graph will be to the left of it, right? So if it's to the left of it, so we are expecting that there will be only x-intercept, but no y-intercept, right? So it's safe that we just only get the x-intercept, never mind the y-intercept here. So let's find the x-intercept. Just review, y equals 0, right? So h of x be equal to 0. So 0 equals 2 times the logarithm of -3 times x plus 1. This is your B and C right here. With base 3 minus 4. Okay? So what you can do here is you can add first 4 to both sides. So what you can have is, if you add 4 here and add 4 here, you get 4 equals 2 times the logarithm of -3 times x plus 1 with base 3. Okay, and then we have to remove 2 here, so we can divide it by 2. So we can isolate the logarithm, okay? So 2 over 2 is 1, so just cancel that out, and 4 over 2 is equal to 2. And it's equal to the logarithm of -3 times x plus 1 with base 3. All right? So in getting the x-intercept, we have to express this in exponential form. Don't forget that. So your base is 3. That's still your base is 3. The exponent is 2, this one. And it should be equal to -3 times x plus 1, right? So 3 squared is equal to 9. And it's equal to -3 times x plus 1. Okay, so we divide first by -3. So what's left is So 9 over negative 3 is negative 3. So negative 3 over negative 3 is 1. So just cancel that out. So what's left is x plus 1. Alright, so the value of x, so when you subtract 1, so x equals negative 4. It's gonna be at negative 4. Alright, where's negative 4? It's gonna be here. Alright, so we need one more point. Okay, we know that the parent function here has a x-intercept at 1, 0, right? At 1, 0. So where will this 1, 0 go? Okay, so just repeat the process earlier. So 1. So for your y value, for your x values, use these informations b and c. So your b, so multiply that by negative 1/3. It's not negative 3, okay? Because it's a vertical shrink. Of course, when you shrink, it has to be less than 1. Okay, so negative, multiply by negative 1/3, and then we subtract 1. Okay, and that's negative 1/3 minus 1, and it's equal to negative 4 over 3. Okay, express your answer in fraction if you want. And that's at negative 4, 3. What about the y value? So that's 0 there. Okay, use your a and d values. A and d values, right? So your a is 2, so just multiply that by 2. Nothing to worry about. Then subtract 4. It's gonna be at negative 4. So alright, so the graph would be at, so that 1, 0 is transformed and it goes to negative 4 over 3, negative 4. And it's approximately 1.33, and then negative 4. It's gonna be here. Okay, so the graph would look like this. It's going to approach this because the 1 point is already here. So what you can do is, okay, and just extend that there. Just take a nice graph, as you know. Okay, all right, so let's just try to get some informations like the domain, the range, of course, all what we needed here. The domain here will be, as you can see, it's on the left, right? It's on the left of negative 2, of negative 1. So your x will be the set of all x such that x is an element of real number where x is less than negative 1. Okay, and for the range, well, that's still real numbers, all real numbers, right? Okay, for the end behaviors, okay, as you can see, as x is going positive, but we cannot have all the numbers here, right? So as x is approaching, what number is that? Negative 1. As x approaches negative 1 from the left, so there's negative here. So what's the behavior of the graph? H of x is approaching negative infinity. Okay, and then one more. As x approaches negative infinity, as it goes to the left, as you can see, it's increasing, right? So h of x is approaching, all right, positive infinity. And for the interval, okay, as you can see, from left to right, so this is negative infinity until 1, negative 1. So from negative infinity to negative 1, as you can see, the graph is decreasing, right? So from left to right, it's decreasing. And there you have it. So that's how you're going to graph your logarithmic function. Okay, thank you.